Okay, welcome to part 2 of the Igneous Rocks. This won't be too long. I always say that. You can't believe me. We're going to talk about igneous intrusions and volcanic features. Igneous intrusion. If your parents are talking and you interrupt them, you are said to intrude. You've kind of forced your way in there. This hot rock underground forces its way under pressure into things. And volcanoes, kind of like zits on the Earth's surface, leave all kinds of things out there, just splattering all over. Ugh. Let's look at some volcanic features, and this is kind of a crazy drawing, which, believe it or not, is not realistic, but occurs on Wikipedia. They use it as an example of, well, all the volcanic features, and it works, so it's kind of fun. Number 1 is called the volcanic stalk. Some people call it the magma chamber. 2 is the bedrock through which all this magma changing to lava is coming through. 3 is the neck, or the pipe, of the volcano. 4, they labeled the base, it's not a big deal. 5 is a sill where the lava or the magma, depending on how close it is to the surface, is forced through pre-existing layers. 6 is a dike. We'll talk about this in a while. 7, those are old layers of ash emitted by the volcano. The side of the volcano is called the flank. 10, we're up to the throat of the volcano. 11, we have a parasitic cone or a side cone. Lava flows. The vents. What am I leaving out? 14. The crater, duh. And if the crater collapses, it's called a caldera. We'll get into this more in the volcano chapter. And the ash cloud. Now, when volcanoes erupt, they pour out a lot of lava sometimes, if they are the basaltic or low silica or smoothly erupting type of volcano, quiet erupting volcanoes. In Arizona, we have all these lava plateaus, and I couldn't figure out for a long time why all this lava flowed out, formed a cliff, and then stopped. It wasn't that way. In many cases, not all, the lava flowed out, in this case, on top of sandstone, and there was a valley here. Imagine this lava flowing down into a valley, and it forms the valley floor. The valley then ends up wearing away, and the basalt rock that's left behind, which was once the bottom of the valley, is now the top of this mesa or plateau. It becomes a cap or protective rock. Kind of crazy. That took years for me to figure out. If I had read a book or had a lecture on it, that would have been easy. Sorry, I just blew it for you. You had a chance to discover this. In the northwest United States, there are huge lava plateaus because there have been lots of eruptions up there. Eruption after eruption after eruption after eruption. It just goes on and on. So if you ever go to the Columbia River, this is what you're going to see. If you're closer to the ocean, it's going to be a lot greener. Beautiful. Let's take a look. Here's, surprise, we're down here, Phoenix area. Go up to Camp Verde, go up to Flagstaff, and then over to the most important town in Arizona, Winslow. Standing on a corner in Winslow, Arizona, my hometown. Take a look. There's these weird black formations here, 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 a few over here, and lots of them here. Let's zoom in on this area here. Same thing. These are black lava plateaus. These are called the Hopi Buttes, all from basaltic lava eruptions. Do we have any basalt in the Phoenix area? Yeah. The Phoenix Mountains, Piestewa Peak? No, not basalt. But if you go up I-17, this mountain here, these mountains here, if you go down the 101, you're traveling past this black stuff, all basalt. The mountains near Deer Valley, we will look at these in just a while. But right now, let's look at this mountain right there. That is all basalt on the southwest corner of 7th and Thunderbird. If you ever go hiking along the North Mountain 101 trails off 7th Street, basalt. If you go north of the 101, which they call the Pima or Beardsley Freeway here, these Mary Knowles items are all basalt. In fact, there's a mine in this one, and they're taking away a lot of it. You have to cross the CAP here. There's a lot of junk back here, sometimes some weirdos back there. No, not science teachers, real weirdos. Now, those were all extrusive formations. Let's talk about things that are forced underground. Again, underneath you, less than 100 miles away, there may be molten stuff. Kind of crazy to think about. This molten stuff is under pressure and it forces its way into the existing rock called the country rock. If it lifts up the overlying layers, this is called a laccolith. It's kind of like a zit that won't pop. I know, a little bit gross, whereas a volcano does pop. A big area, bigger than 100 square kilometers, is called a batholith. A lith being a piece of stone, and a bath, well, like a bath. If it forces its way vertically through layers of rock, it's called a dike, like the Dutch boy who stuck his finger into the dike. And if it goes sideways, like the bottom of your window, it's called the sill. And on occasion, we get these weird things called diatremes, where stuff from down here is pooched up really quickly. In the case of South Africa, it brought those minerals that form only down deep up to the surface. What were some of those minerals? Diamonds, platinum. So if you can find diatremes, you might be able to mine them. What's weird is, let's go back a little bit. These things in northern Arizona, in the worthless lands that we left behind for the Indians, I think someday they will find out are diatremes and they'll start mining for diamonds and the Hopi will be rich. Very cool and kind of fair. Now, volcanic necks. What happens when the volcano wears away? This kind of thing. This is Shiprock, New Mexico. Yes, this is a real photo. Here's the old volcanic neck. You have to imagine that the surface of the earth was way on top of this. Here was the molten material trying to get its way up through the ground. And here was a crack through which the molten material intruded itself. There's the dike, and here's an old volcanic neck. Here's another version of what happens underground. Again, we don't see this because we just walk on the surface and see just the least bit of evidence. But if we could x-ray the earth, this is what we'd see. This is shiprock with dikes going out in all directions. Here is a sill. I think this is in Antarctica. It isn't all covered with ice. And this is a dia-based sill, I believe, that's forced its way into pre-existing rock. Here is a dike that's forced its way into rock that was there earlier. Now, batholiths can cover huge areas. Let's go back to the batholith. These things, they're also called plutons, after Pluto, the god of the underworld, hot, molten, sulfur, fire and brimstone. That's why. When the stuff on top of this wears down, we end up with these batholiths on the surface, and then we come along and carve presidential faces into them. Notice that the more recently exposed rock is less oxidized than the older rock. This is all granite. Batholiths most often are granite. Oh man, what is this? This is granite. My hand. And here's a rock that if you look closely is kind of molten around the outside. How did this form? This is called a xenolith. Xeno being strange and lith being stone. Here's how it happened. When this hot stuff forms and pushes its way to the surface, it will bake anything around it. Sometimes you'll find the surface underneath a lava flow that's been baked. On the way to Flagstaff, along the I-17, over to the right as you're heading north, you'll see columns of basalt. And underneath those columns, there will be old soil that's been baked, and it looks just like terracotta, but it's formed into hexagons. It is so cool. So the pre-existing rock ends up with a baked zone. The plutonic rock ends up with a chilled zone. On occasion, pieces of the country rock, the pre-existing rock, fall into this molten material. Ah, it hurts. Well, not really. They can handle the heat pretty well. And they get baked. This is a xenolith that fell into molten rock. It's really kind of cool we see this on the surface because it happens way underground. Now, important point, granite with water melts at 650 degrees. It's weird, but subducting granite or materials with water melt at a lower temperature. Without water, it's over 1,000 degrees Celsius. Here is a laccolith. Everything on top has been worn away. This is left behind. Now, way underneath us, like the lava lamp example that I don't think I've shown you yet, but think of a lava lamp. The little bubbles get heated, they rise. Well, that's happening in the earth, and this kind of stuff rises underneath us and forms these large plutons. If you get enough plutons together, you get a batholith. These little molten things are called diapirs, diapirs. And a good portion of the mountain backbone of the continents is this stuff. Why don't we see it? Well, because these rocks wear down and form sedimentary rocks on top. Here are huge batholiths that form the Sierra Nevadas and the Idaho batholith. Why does this happen? Subducting plate of the Pacific goes underneath us. It has a lot of water. It has a low melting point. This stuff melts, but it's very viscous. These diapirs rise in plutons, little lava lamp bubbles, and they get up to a point where they reach equilibrium and they get stuck. And they form this big batholith. As the stuff on top of here wears away, because this really does rise over time, we end up with things like this in the McDowell Mountains, Scottsdale, Tom's Thumb. Great trails out here. Please pick up your trash and your dog poo. Ranger Jeff here, boys and girls. This is all granite, formed from this kind of stuff. We have it even here in the Phoenix area. I have no idea why I stuck that in here again. Now, one more thing about this stuff underground. Because we have these plutons down here, we can drill down into it if they aren't too far down. We can inject water. That water will turn to steam, and if we provide exhaust wells, we can take that exhausting steam, which is expanded about 1,500 times, and use it to drive magnets attached to a fan inside of a wire, and that creates a generator. At Los Alamos National Laboratory, this is one of the web pages I've created there, there was an experiment a few years ago to do this, creating geothermal energy. It can be done. Funding was cut for it for some reason, but it can be done. Scientists have shown it to be true. If you want to read more about it, here is the link. And that's it. Thanks for watching.